Good morning, students. Welcome you all for next generation learning. Today, we are going to see the subject physics and class 9. Topic is waves and wave properties. The first question, why are we able to see? Because there is a light. If there is no light, we cannot see the object. So this is a common concept, you know that. If there is a light, we can see the object. If there is a no light, we cannot see the object. And what is light? Light is a wave. So what is a wave? A wave is a disturbance that carries energy from place to place. A wave does not carry matter with it, it just moves the matter as it goes through it. Example, if you throw a stone into the pot of water, here the water is a matter and the stone create disturbance in the water. Due to the disturbance, the waves are produced on the surface of the matter. Here, the wave energy only transfer from one place to another. The particles present in the water does not move. So, from this we can say that a wave is a disturbance that carries energy from place to place. It carries only energy. It does not carry any particles. A wave does not carry matter with it. It just moves the matter as it goes through it. Some waves do not need matter to be able to move. Example, space. These are called electromagnetic wave. So the wave need medium to travel. That waves are called mechanical wave. The waves do not need medium to travel. That waves are called electromagnetic waves. Otherwise, we can say that EM waves. Some waves must not have a medium in order to move. These are called mechanical wave. If you take a mechanical wave, it does not travel. It must need a medium to travel. It does not travel in the space because in vacuum or space there is no particles. If there is no particles, these type of waves are not travel into that. And the next topic is wave types. There are the two type of waves. One is transverse wave and another one is longitudinal wave. What is meant by transverse wave? Waves in which the medium moves at right angles to the direction of the wave. Example, if you take a thread and tie it at one end, hold it at the other end. Just given a shake to this thread. You can able to see the thread moves like that. So this is a wave. Here the particles present in the medium are moves at a right angle to the direction of the wave. Look at the second picture, you can understand that this is a air medium. So I tie it one end of the thread with cylinder and another one end is I holder. So the air medium have number of particles in it. So when I give a shake to the thread, it makes a wave. So the particles in the air medium are moving up and down. The wave moving in this direction. So waves in which the medium moves at right angles to the direction of the wave. This is the direction of the wave. The particles are moving up and down. So it is right angle to the direction of the wave. In a transverse wave, the particles in the medium are moving up and down direction. That means it is right angles to the direction of the wave. Look here, the particles are moving in down direction and up direction. Due to that, the wave is formed. The initial position of the particles are in a straight line. When I given the shake, the particles are started to move up and down. Due to that, the wave is produced. Parts of transverse wave. There are the two parts are present in the transverse wave. One is crest and another one is trough. The highest point of the wave is called crest. So, if you take a wave, this is the highest point, this is the lowest point. So, the highest point of the wave is called crest and the lowest point of the wave is called trough. It's shown clearly in the diagram. The next wave is compressional or longitudinal wave. So what is meant by compressional or longitudinal wave? Waves in which the medium moves back and forth in the same direction as the wave. Look at this diagram. Here I took one slinky. When I give some force at one end, it moves like that. So here the particles present in the medium move back and forth. The direction of the force is in this direction. So the particles and the direction of the wave travel in same direction. Are you clear? In a longitudinal wave, the particles are moving back and forth. The direction of the force is in this direction. Here the particles direction and the direction of the wave is same. Why it is called compressional wave? Look here. This is the direction of the wave. The particles are moving back and forth. And when I took the slingy, I will give the force at one end. It gives compression and rarefaction. The compression is, in a compression, the more waves are present. In a rarefaction, only the few waves are present. So the compression and rarefaction are continuously produced. The particles in the mediums are moving like that. In a compression area, the particles are more. In rarefaction area, the particles are less. So parts of longitudinal waves. Where the particles are close together, that is called compression. Where the particles are spread apart, that is called rarefaction. So it is shown clearly in the image. Here the particles are close together, so it is called compression. Here the particles are less, so this is called rarefaction. Wave properties. Dear students, I hope you understood what is meant by transverse wave and longitudinal wave. Depending upon the movement of the particles present at the medium, we can divide the two type of waves. One is a transverse wave and another one is a longitudinal wave. When the particles in the medium moving up and down direction, it creates transverse wave. When the particles in the medium move back and forth, it creates longitudinal wave. So these type of waves have some properties. The first property is wavelength. The distance between one point on a wave and the exact same place on the next wave. That is called wavelength. Look at this diagram. This is a wave. The distance between one point on a wave and exact same place on the next wave, that is called wavelength. It is clearly shown in the image. It start with the crest and end with crest. Maybe if it start with trough, it end with trough. So the distance between one point on a wave and the exact same place on the next wave, that is called wavelength. It is represented by the letter lambda. In a transverse wave, if you take a transverse wave, the crest to crest distance is called wavelength, or trough to trough distance is called wavelength. If you take a longitudinal wave, compression to compression is called wavelength. Rarefaction to rarefaction is called wavelength. The next property is frequency. What is meant by frequency? How many waves go past a point in 1 second? The unit of measurement is hertz. If you take any point from this area in 1 second, how many waves are passed out? This is called frequency. How many waves go past a point in 1 second? That is called frequency. It is measured by the unit hertz. The higher the frequency, the more energy in the wave. 10 waves going past in 1 second, the frequency is 10 hertz. Example, if you take any point, in this point in a 1 second, the 10 waves are crossed out in this point. So what is the frequency of this wave? The frequency of this wave is 10 hertz. If 1000 waves go past in 1 second, the frequency is 1000 hertz. 1 million waves going past means the frequency is 1 million hertz. The next term is amplitude. How far the medium moves from rest position, that is called amplitude. Remember that for a transverse wave, the highest point is the crest and the lowest point is trough. If you take a transverse wave, this is a transverse wave, this is a crest and this is a trough. The highest point is crest and the lowest point is trough. So how far the medium moves from rest position, that is called amplitude. So the maximum, the main position of the maximum position of the particle is called amplitude. If you take a wave, this is a wave, so this is a maximum position of the wave. This is called amplitude. Remember that for compressional wave, the point where the medium is close together are called compression, and the area where the medium are spread apart are called rarefaction. This concept we already know that if you take a medium, the particles are close together, that is called compression. If the particles are less, that is called rarefaction. If you take a slinky, this is a compression and this is a rarefaction. The closer together and further apart the particles are, the larger the amplitude. So in a compression area, the amplitude is maximum. The energy of a wave is proportional to the square of its amplitude. Mathematically, we can write it E equal to CA squared. Here, the E is the energy of the wave, A is the amplitude. So, the energy of a wave is proportional to the square of the amplitude. In a square, because of the square, I written A squared, where E is the energy and C is a constant, depends on the medium, and A is the amplitude. For example, if the amplitude is equal to 3 unit, we assume C equal to 1. So I can substitute E equal to, instead of C, I substitute 1. A value is 3, so I squared. 3 squared equal to 1. 3 squared means 9. So 1 into 9 equal to 9 units. So the energy of the given wave is 9 units. Look here. Here I drawn the graph between energy and amplitude. I given the readings also. Amplitude values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The corresponding the energy values also given. Note that when the amplitude of a wave is 1 unit, the energy is 1 unit. Look here. Here in the first reading, the amplitude value is a 1. So the energy value also 1. So note that when the amplitude of a wave is a 1 unit, the energy is 1 unit. When the amplitude is doubled, the energy is quadrupled. Here the amplitude value is 2, that means it is doubled, and the energy value is 4. When the energy is 10 times greater, the energy is, when the amplitude is 10 times, when the energy is 10 times greater, the amplitude is 100 times greater. No, sorry my dear students. When the amplitude is 10 times greater, the energy is 100 times greater. Look here the amplitude is at 10, the energy is 100. So comparing to the amplitude, the energy is 10 times greater. The next property is wave speed. Depends on the medium in which the wave is traveling. It varies solid, liquids and gases. If I take solid medium and liquid medium and gas medium. In a solid, the wave move very slow. In a liquid, it increase the speed. In a gas, it moves very fast. So depending on the medium, the solid medium, a liquid medium and a gas medium, the speed of the wave is decreased or increased. In mathematical way to calculate speed, how we can calculate the speed? Wave speed equal to wavelength into frequency. We already know that the wavelength and frequency. The wavelength is distance between the one crest to another crest or one trough to another trough if you take a transverse wave. The frequency is the number of waves passed out in 1 second at a particular point. The wavelength is in meter, the frequency in hertz. The wave speed is represented by the letter V and the wavelength is F. The frequency is, the wavelength is lambda and frequency is F. V is wave speed. If a wave has a wavelength 2 meter and frequency 50 hertz, what is its speed? You have to put the values in the equation. Speed equal to 2 meter into 500 hertz. We can get 1000 meter per second. Why I written meter per second? Because the unit of speed is meter per second. Changing wave direction. How we can change the wave direction? By reflection, we can change the direction of a wave. When waves bounce off a surface, example, if you take any wall, this is the wall, when the wave fall on the wall, it bounce back. So here the wave direction is changed because of the reflection. When waves bounce off a surface, it can change their direction. If the surface is a flat, the angle at which wave hits the surface will be the same as the angle at which it leaves the surface. If you take any surface, the surface is a flat and smooth, the wave fall on the surface, it will reflect. Due to that, it change their direction. This is a normal line. This is a normal line. This is angle of incidence. This is angle of refraction. If the surface is a flat, the angle at which the wave hits the surface will be the same as the angle at which it leaves the surface. It create an angle with the surface 40 degree means it leave with the surface also 40 degree. That means the angle of incidence is angle of incidence is equal to angle of reflection. This is called law of reflection. This concept we already studied in the 8th standard. What is meant by refraction? Waves can bend. This happens when a wave enters a new medium and its speed changes. The amount of bending depends on the medium it is entering. Look here, this is a diagram. Here I pour the water and above the water air is present. Here the two mediums are present. One is air medium and another one is a water medium. When the wave travel from one medium to another medium, the speed and the direction of a wave is changed. So when it enter into one medium and one medium into another medium, the wave can bend. Due to that, the speed and the direction of the wave is changed. This is called refraction. The next one is diffraction. The bending of waves around an object is called diffraction. The amount of bending depends on the size of the obstacles and the size of the wave. Large obstacle, small wavelength, low diffraction. Small obstacle, large wavelength, large diffraction. Example, maybe the wall is present here. When the wave travel in this direction, this is an obstacle for this wave, so it can bend along this object and it move into another side. So this bending of light is called diffraction. The bending of light depends upon the size of the obstacle. Thank you for watching. Dear students, I hope you understood what is meant by wave. A wave is a disturbance and the energy only transferred from one point to another point. The particles in the medium does not move from one point to another point. And there are the two type of waves we studied. One is a transverse wave and another one is a longitudinal wave. Depending upon the movement of the particles present at the medium, we can divide these two waves, transverse and longitudinal. The particles move up and down direction, it creates a transverse wave. The particles move back and forth, it creates a longitudinal wave. The next we learned the properties of wave. So what are the properties? One is a wavelength and another one is a frequency, the amplitude and wave speed. The next we learned how the wave change their direction. Because of a reflection, refraction, diffraction, the wave can change their direction. Thank you for watching.